Hi guys, this is Miss Gold. Today's lesson is Module 4, Lesson 5, Percent Error in Changes Problems. Your outcomes for today's lesson are given the exact value x of a quantity and an approximate value a of the quantity. Students use the absolute error, which is the absolute value of a minus x, to compute the percent error by using the formula the absolute value of a minus x divided by the absolute value of x multiplied by 100. Students understand the meaning of percent error as the absolute error is of the exact value. Students understand that when an exact value is not known, an estimate of the percent error can still be computed when given a range determined by two inclusive values. Students solve percent problems where quantities and percents change. Before we begin, we need to address some new vocabulary here. We have percent error is our general topic. So before we look into the actual formula for percent error, we have to know one of the pieces of it is the absolute error. So notice the word absolute alludes to the absolute value. So what they're really saying is we're not going to account for positives and negatives when we're computing this number. We're only just going to look at it as a positive. So the definition is given the exact value of x of a quantity and an approximate value a of the quantity. The absolute error is the absolute value of a minus x. The part that I really like to think of this as is the absolute value of measured minus the actual. This is our absolute error. So whatever measurement you or the person found, that's going to go first. Then we're going to subtract the actual number, the measurement that we know it to actually be. For percent error, what we're then going to do is divide by the absolute value of the actual. So essentially what I like to memorize this as is measured minus actual over actual. And we need to know that the result is always going to be a positive, so that's why we have absolute values on it. And because we're talking about a percent, they're multiplying by 100, so you can take the decimal that you get and turn it back into a percent, giving us a final percent error. So what percent error is really talking about is when you do some measurements. We try to get our measurements as exact as possible, but they're not going to be an exact, it's more of an approximation. So this is why we use percent error. What we're really looking at is how far off is our measurement from the actual value, and looking at that in terms of a percentage. So let's take a look at example 1. 3 students measured the digital length of a 15-inch computer monitor. Find the absolute error for the following problems. Explain what the absolute error means in the context. So the first person we have is Taylor's measurement, and we see from our table here that Taylor's measurement was 15 2/8 of an inch. So we learned that the absolute error is the absolute value of the measured value. So the measured value in this case is 15 2/8. And we're going to subtract out the actual value, which in this case is 15 because they told us it is a 15-inch diagonal length for the computer monitor. So when I subtract those two and take the absolute value, I get 2/8. Connor's measurement was 15 4/8. So we can take the absolute value of the measured minus the actual, which is 15. And when I subtract those two, I get 4/8, which reduces to 1/2. 2/8 up here we could also reduce to 1/4. You'll notice that Jordan's measurement, Jordan actually got the same measurement as Connor did. So we're going to say that Jordan's is the same as Connor's. So we're asked to explain what the absolute error means in the context. So what we're talking about here is the measurements of a diagonal length of a 15-inch computer monitor. So the absolute error is basically telling us the distance of the measured value from the actual value. Continuing on to example 2, we're going to be looking at the same scenario of the 15-inch diagonal length of a computer monitor and the measurements for the 3 students. Part A says to find the percent error for Taylor's measurement 1, and what does this mean? So we already know that our formula is the absolute value of the measured, which we found in our previous problem to be 15 and 2/8, minus the actual measurement, which is 15 inches, divided by the actual, which we just said is 15. Okay, when I subtract these and simplify, we get 1/60th. Because we're looking for a percent, we're going to multiply by 100. And when I do that, I get 1 2/3%. So what does this mean in the context of the scenario? What it's telling us is that Taylor's measurements were off by 1 2/3%, which is a very, very small percentage. So Taylor actually did a pretty good job of measuring the diagonal length of this computer screen. From example 1, part B, find the percent error for Connor's measurement 1, and what does this mean? So again, we are going to take the absolute value of the measured value for Connor, that was 15 4/8, minus the actual value, which was 15, and divided by the actual. When I simplify this, I get 1/30. We're multiplying by 100 so we can turn it into a percent. And I get 3 1/3. So in the context of the scenario, it means that Connor's measurement was off by 3 1/3%. So comparably to Taylor's measurement, his measurement was not as close. Part C, we know that Connor and Jordan had the same measurement, so they would have the same percent error. So looking at all 3 of these students, we can tell that the one student that was the most accurate was Taylor, who was only off by 1 2/3%, which is an extremely small value. So what's the purpose of finding percent error? There is several things that you can do with this information, but the general idea to find percent error is to determine how accurate a measurement is.